Renewable energy from wind is an important part of our green energy future. Wind turbines are now a common sight in many areas. But there is more to the construction of a wind turbine than what we see on the surface. These large structures need a solid foundation. Most of the support lies below the ground. A common type of foundation is the gravity-based foundation. It is composed of concrete that is reinforced with steel bars. These bars are important to keep the foundation together. The foundation supports the weight of the tower and the large overturning loads resulting from turbine operation. When the wind blows against the turbine, the top surface of the foundation on the upwind, or windward, side of the foundation and the bottom surface on the downwind, or leeward, side of the foundation are under tension and tempted to pull apart, while the bottom of the upwind side and the top of the downwind side are under compression. Concrete is strong in compression but very weak in tension. That is where steel, a material that is strong in tension, comes in to save the day. Reinforcement, or rebar, gives tensile strength to concrete that is in tension to keep it together and prevent the tower from toppling. As the wind can blow in any direction, most foundation designs are circular, and rebar is laid out in an axisymmetric pattern. The foundation starts with an anchor bolt cage. These long bolts will attach to the turbine tower and are the basis for the center of the foundation. The first layer of reinforcement is a series of circular bars followed by a long set of radial bars as well as another short set of radial bars. These bars form a stable base. Next comes a series of long vertical bars that support the center section and connect the pedestal to the foundation slab. Shear bars are placed around the conical section. These bars are important to supplement the shear capacity of the foundation concrete in resisting shear stresses in the foundation slab. The shear bars also work with the chair bars, or standees, to support the top mat reinforcement and tie the top and bottom mats of rebar together. The C-edge bars stabilize the perimeter edge of the foundation. A top mat of rebar is placed consisting of a set of circular bars as well as long and short radial segments very similar to the bottom mat. The base slab concrete is then cast. Once the base slab concrete has gained sufficient strength, the cold joint between the slab and the pedestal is cleaned and a small set of chair bars are inserted into the pedestal area to support the bars that will be placed above. The outside of the pedestal is bound by hoops and strengthened throughout by hundreds of hairpin bars. The pedestal is topped off by a radial set of L-shaped bars and a small mat in the center. The importance of the pedestal section is shown by the large amount of reinforcement needed. The pedestal concrete is then poured. After the required concrete curing time, the excavated area is backfilled to finished graded in compacted layers before it becomes ready for the construction of the tower. Because wind turbines produce constantly shifting forces, the foundation must be designed to withstand these forces as well as resist the repeated strain that allows for many years of service. Effective foundation design balances the requirements of lasting support for the life of the turbine and the saving of resources, which translate to reduced financial and environmental costs.